Okay, so what we're going to do here is uh, one of the things that Ron Cowan observed was there's information that's coating the walls of the compartments of space itself, the ether, and it's everywhere. And that appears to be a good candidate for what Carl Jung called the collective unconscious. But since it's information, it has algorithms in it. It can process and it can store things, and that leads to the creation of patterns and forms and even archetypes here. So all of these things come out of what Ron observed, and just following this thing through leads to a whole series of things that we're going to cover over the next, not just this class, so next probably two or three classes. So, we'll see where it goes. But it's a very, very deep concept, and it's all around us, and yet people don't realize it. So that's why we're going to spend the time on it. So here we
Okay.
go. Um, we start off with what in the world is the problem that we're addressing here? And if you go back and look into these myths that are floating around, the internet is great for these things. There appeared to be a real golden age that was on Earth that was led by Atlantis. It was a global civilization. Atlantis was just the latest one. Before that, there was this Lemuria that appears to be in the Pacific, and before that, there was Hyperborea. And Hyperborea appears to be having some activity in Greenland, which is why Trump is going crazy trying to take over Greenland. There's something they've discovered in Greenland, so we'll see what that is. Uh,
Oh, okay.
the press is not picking up on this, but there's a lot of other people that are saying no. There really is something in the Danes don't know about this. It was discovered by the U.S. military. So the other thing to keep in mind with this golden age that occurred, which was global, when we'll see evidence that all over the place, was all the mystics say that the true reality is not what you see with your eyes, that it's something far deeper. Okay, so that's a real problem. Like, what am I looking at if it's not reality? So, and then we have this Hindu notion of life being cyclic. So there's apparently a soul that lives forever, and it incarnates again and again with different bodies throughout the ages, and experiences more and more, and hopefully grows and becomes a more complete entity at the end of it all. So there's the cyclic side of things. This is an issue because a lot of people, when you talk to them, they don't give this really a lot of thought, and they say, "Well, I'm just going to die, and that's it." And then
What is
we
the
have this
problem?
thing we've
You
been
have a problem.
walking around.
Did you mute it?
Can you
What?
talk for a minute?
Mute it.
Mute it. I don't think I can.
Hmm?
Wait, oh, here it is up here. We've been talking about this, that we've had 500 years of science really going at it.
Okay, silence. Now, what do you want?
They concluded
Well,
I'm
they've
sorry, it's
got
China.
uh,
I didn't expect it. But I didn't-
no, but then you also didn't tell me.
5% of the
So it's
universe
like
has been
you also
studied.
didn't tell me.
So they don't know about
When
the other
he called you,
95%.
you could
We'll
have
just
gone.
take a break
You
here.
could have
Well,
say, Karina, I'm sorry, I have to do this tonight.
Oh, okay.
I just feel constantly I get abandoned. Well, I'm telling you what I experienced.
Okay, all right.
Okay.
Okay.
you okay?
Yeah,
Okay,
sorry.
no problem. So the other thing that we've talked about here is after 500 years of science going at it and becoming more and more proficient. They've concluded they've been studying 5% of the universe, meaning the mass and the energy in total 5%, and the other 95% is called dark. So this is a big problem because you really we don't see the true reality, and we've been studying 5% of it. Like, who's kidding who? What's going on? And then in the background is this side of things of we see billions of stars in our galaxy. We see billions of galaxies. So all of that suggests that life is very common throughout the universe. And the only evidence that we have to date is that there's lots of encounters with spirits or people, claim to be visited with extraterrestrials in every age all around the planet. So these are all things that are lurking underneath it all. So let's see where it goes. We touched on Atlantis, and just to pick up on that, Atlantis appears to have been really a high point for at least 1,000 years, and apparently it was subverted by some bad extraterrestrials that took it down. But there was a balance in this between spirituality and materialism that complemented one another. There was a basic part of daily life in everyone. And when Atlantis realized that the whole continent was going to sink in the ocean, it sent out colonies to preserve its knowledge, probably in Egypt and the Yucatan, Bimini, the Gobi Desert, the Iberian Peninsula,
Just to serve it.
Mesopotamia, and so forth. So, what in the world did Atlantis know? Well, Atlantis had answers to these things. The first one was this issue of what's called dark matter. Uh, we have an astronomer, George Zwicky, at Caltech in the 30s, and he saw spiral galaxies. Here's a picture of a spiral galaxy. So there's, hundreds of millions, billions of stars in this. And so he just did some calculations. He said, well, suppose they're all the mass of our sun, and all these stars are attracting one another by gravity, and the thing is spinning clearly. I can see it spinning. So how stable is it? And he showed that if gravitation was the only thing involved here between these stars, it's just not strong enough, and this thing would fly apart within hundreds of thousands of years. And yet he sees these galaxies everywhere, so they clearly are stable. So there must be something that's holding it together. So he just postulated that there was extra matter. It was because he's German, he called it Dunkel, which is German for dark. And he did a calculation suggested that if there was really 5 times as much dark matter as matter, then these spinning galaxies would be stable. So that's what we've come up with today, that apparently 27% of the universe is dark matter and only 5% is matter. So dark matter is really prevalent here. We just can't see it. We don't have any instruments yet that allow us to see it. Uh, but if that's the case, what else don't we know? And Ron Cowan suggested a whole bunch of things on this, so we'll come to clarify this. Then we had dark energy, which is the other 68% of the universe. So there was a chap at uh, in just by the Grand Canyon. There was a nice observatory there. Percival Lowell set it up, and that's where he looked at Mars with a telescope, and he saw channels, and the press interpreted that to be canals, which is what he never said. But anyway, there were channels for water on Mars, and the telescopes were good enough that his associate, Vesto Slipher, this is really a great name, Vesto Slipher, uh, in 1910, 1912, he looked at the telescope was good enough to see these other blotches of light, and he could see that they were actually galaxies, and that in fact they're moving away from one another. He could see that. And Edwin Hubble had access to a much better telescope in the 1920s on Mount Palomar, And so he confirmed what Vesto saw, but he also was able to quantify how fast these things are moving apart. And it suggested that they weren't really moving apart. It was that space itself was expanding. So if I'm here with these two things and space expands, we move apart. That's that's what it means to have expanding space. So this energy that's in this apparently is due to uh, what Ron saw, that the compartments of space itself contain energy, and this energy is strong enough that it will expand the space compartment just a little bit. But if it expands all the space compartments throughout the entire universe, everything goes away from everything else, and so forth. So, uh, dark energy. And then this takes us back to really what is called cosmology, that if all the galaxies are moving away from one another because space is expanding, then the converse is true, that they probably all started off at one point and then started to expand out. Okay, you can't just continually be expanding. You have to start somewhere. And so there's two different phenomena that are going on here at the start. The first one is that there's really no mass in anything, and then this entity called the Higgs boson gets created. Ron saw this. A Higgs boson gets created for matter, and another one for dark matter. So the Higgs boson uh, can itself generate energy throughout all of the universe, all of the space compartments we're talking about, and the end result is that what had no matter, no mass whatsoever, all of a sudden has mass. So electrons have mass, protons have mass, neutrons have mass, and so forth, all due to this creation of this Higgs boson. Now, what's implicit in that is there were no Higgs bosons. So when the Higgs boson shut down, that suggests that that's why everything collapsed. That we have a Higgs boson that makes things expand. If the Higgs boson has a timer on it or something and it stops, it gets turned off, then there's no reason to expand anymore. And in fact, everything will end up collapsing back to a point, which is a really key observation that Ron came up with. So the other side of things is when everything is squashed together, all the compartments of space are compressed and so forth, and then they start to expand. They get compressed just so much, and then that's it. And now they start to bounce back. They're going to expand in clumps, and this is some clump of space will expand, and then another clump will expand, and each of these little clumps, as they expand, will create a universe. And so there's probably billions of universes being that were created when this bounce occurred. And when the space compartments expand, they do so very, very rapidly. They go through 30 orders of magnitude of change in size. So that's such a big number, it's impossible to comprehend. But space itself is expanding, and these Higgs bosons are kicking in to help this all out. And so this suggests some of the mechanisms in cosmology for why the universe undergoes these cycles of expansion and contraction again and again. So we probably started an expansion trillions of years ago, and it's continuing today, but who knows? It's clearly going to shut down and we're going to go back to a contraction, and we won't be around to see that, but our souls will be. So this raises the question of where in the world does this dark matter and dark energy reside? And one possibility that people have picked up on is we can't see it because it's in other dimensions. And that's why it's called dark. We just can't see these other dimensions. So the sizing we've always done is that if 1/20th or 5% of the mass and energy is in three dimensions, three spatial dimensions, then 100% of it is in 20 times 3 or 60 spatial dimensions. And that isn't too far off. The correct answer appears to be 24 real spatial dimensions or 12 complex space dimensions, where each complex dimension has two parts to it, a real and an orthogonal or imaginary part. So this shows the extra dimensions should be enough to account for where all this other dark matter and dark energy reside. Now, the other thing that Ron observed here was, again, we saw a bounce, and he saw that at the start of the universe, under very deep meditation, he saw all the space compartments, which is the ether foam that makes up space, all compressed down to some basic minimum size. And when they'd all done that, then they just started to bounce back. And some of them started to expand very rapidly by inflation, and then another patch and another patch and so forth, all of which he saw due to this Higgs boson that was being uh, coming into existence then for matter and for dark matter. And this matches what the Hindus saw in their Vedic writings, that the universe always is expanding and collapsing, expanding and collapsing. But the bounce that occurred here uh, again occurred because there were no Higgs bosons. That was why it was collapsing. But when they bounced back, then the Higgs bosons were created, and that led to energy being put throughout space, which led to the dark energy being everywhere. And so there wasn't any Big Bang, a la what you would read in the Bible. It was rather a big bounce and so forth. So once Ron saw this, then we start to see this inflation occurring of the space compartments, very rapidly expanding. And here's what the problem is. There's a lot of measurements that have been done from the 1960s onward that show that there was a Big Bang, and it was 13.8 billion years ago. And the problem is, if there was no, if there was only a bounce, there's clear evidence there was a bang. So what in the world could this bang be due to? And the simplest explanation for this, due to Occam, this English chap who said you always pick the simplest explanation that fits the facts, is that our universe collided with another universe. There's a lot of other universes out there, and it isn't out of the question for us to have collided with one 13.8 billion years ago. But that was not an epic of creation. So that's setting the stage for what Ron came up with for really the fundamental concepts that are underlying all this stuff. So that's what we're going to run through now. And the key thing here is we draw on Plato, and Plato learned everything from the Egyptians that were probably a colony of Atlantis, and Pythagoras went to Egypt before Plato, and Pythagoras probably taught a lot of this to Plato. And so Plato has come back and said that there are these forms, which are called Platonic forms. And these forms are really critical toward understanding everything, particularly in mathematical physics, in the structure of our universe. So these Platonic forms provide a bridge between what some would call ancient philosophy and modern science. It suggests that the universe isn't just a collection of random matter, but is governed by some underlying invisible structure of mathematical truths. And again, this is what Plato said. What Ron Cowan saw was information was everywhere, and the algorithms are in fact what create these forms that Plato was describing. But Plato didn't have a computer background. He wasn't thinking of that when he was doing this. The forms are all around us, though. We see forms for the planets. They're spherical. We see forms, for human beings. We have two arms, two legs, ahead, and so forth. That's a useful form for things. We see the forms of the different animals and the plants and the trees. And so these forms is what Plato saw. And this there's something that creates these forms that is invisible. And Ron believes it was due to the information that's everywhere that controls everything. So let's take a look. Plato argued the physical world we perceive through our senses is really a shadow of a higher unchanging reality, and he called these perfect archetypes forms or eidos. In the physical world, they're imperfect, they're changing, and they're deceptive. For example, if we draw a circle, well, it's really never perfect. And perfect means perfect, okay? There's little wiggles to it as we draw it with our hand. There's imperfections in the pencil or the pen that we're using. So it's always imperfect. But in the world of forms, circles are perfect, and they are in fact eternal, and they're accessible through some mechanism. Here we believe it's really meditation, but Plato thought it was through reason, through the mathematical definition of a circle. But the mathematical definition of a circle is another example of a form. A circle is a form. So. So mathematical physics, to describe all this, is really Plato in action. And so most physicists really operate implicitly following Plato, even if they don't realize it. When you write down any sort of equation, like from Newton, where the force equals the mass times the acceleration, or following Einstein, where the energy is the mass times the speed of light squared, we're assuming there's some sort of rule that exists that's independent of our observations that makes this true. And this is what is called the unreasonable effectiveness of mathematics. We couldn't write these things down mathematically if they weren't in fact true, but they're too simple. They're too obvious. How in the world can we possibly come to this conclusion? So the the thought that Plato came up with is that they're mathematical objects, say numbers, the integers one, two, three, or other entities. For example, vector spaces of two, three, four dimensions, and so forth. And these aren't inventions of man. These are things that are these forms. They're implicit there in this information, and these objects that are there just arise. We discover these things. We're not inventing them. They're there all the time, and we discover them through what is called mathematics. So they're not created. The universe obeys these laws with a precision that suggests that the math is more real than the physical matter it describes, or to put it differently, that these rules that we're talking about can control everything. That's implicit in this is that you can control these forces and energy and make it do what you want. So let's follow this through some more. A key notion here is there's symmetry everywhere, wherever we look. We take a look at a human, we're symmetrical about our axis. We have a left side and a right side, and they're, in some sense, mirror images of one another. An arm, a leg, a chest, a half of a head matches the other side. In modern particle physics, uh, they don't really think of things as matter. They focus on the symmetries there that arise out of this, and this is where Plato again kicks in. Plato believed there were four elements: earth, air, fire, and water, and they were associated with these geometric shapes: the cube, the octahedron, the tetrahedron, and the icosahedron. Now, these are all perfect so-called Platonic solids, these four different entities here. And in modern physics, they end up describing relations between various particles as as being associated with certain symmetries. they just talk about the symmetries rather than talking about the particles. So this is a typical thing here. And so in this sense, a proton is essentially a physical manifestation of a particular mathematical symmetry, which is something that Plato would be very happy with. So we see, Plato 2,500 years ago is coming into his own today. And there's also a view that says, with some physicists, that the universe is essentially information, but this is driven by a 21st century view of what Plato saw, that the form is the code or the math, and the physical world is the output or the simulation of it all. And here's a little table that summarizes that. And that appears from what Ron saw to be more true than anyone thought. That is, the information not only controls the patterns that we're talking about here, but it also controls all the forces that are there and how these things evolve over time, how they interact with one another, which is even deeper. It is not realized yet by physicists that that's indeed possible. There's a couple of very popular, well-known physicists that you'll come across. Roger Penrose won the Nobel Prize in physics for a lot of really outstanding theoretical math that he did. And another chap, Max Tegmark, who's at MIT, writes a lot of popular stuff on physics. And they're both all over the internet. You have no problem finding lectures by them and so forth. But they're both Platonists at heart, that they interpret the relationship between math and reality using these forms that Plato came up with, but they do it in totally different ways. So Penrose uses the realms of Plato as one of three interacting worlds, and Tegmark argues that the Platonic realm is the only one that actually exists. So let's take a look at this. Penrose said, well, there's these three worlds, they're layers of existence. There's the Platonic world, which he calls the world of mathematics, which is a realm of absolute eternal truths, and these exist independently of us. Then there's the physical world, which is the universe of matter and energy, which is a shadow of the Platonic world because only a small, specific slice of mathematics actually governs our physics. And that's what he's arguing. And then there's a world of consciousness, which is different than the other two worlds. And our internal experience, he argues that the mind can really access this Platonic world to do things like math. But he believes that it's really not computational, that there's no way that you could truly understand math the way that humans do. And that is what many mathematicians believe. That is, that there's certain things that computers can do, but there's questions that come up that no computer can really deal with, such as there's a sentence there, which is, this sentence is false. Well, if the sentence is false, then it's true. Okay, so you have a problem here. Well, is it true? Because if it's true, it says though the sentence is false. And so these are questions that arise that no computer can deal with. It's beyond the realm of computation. It's outside of that. And that's where human consciousness kicks in, according to Penrose. So he has always wondered why the physical world is so perfectly governed by this Platonic world, and why this mental world can even perceive the Platonic world. So this is how he views what we would call reality. But Max Tegmark has a mathematical universe hypothesis, MUH. So he's much more radical, and he says there's really only one thing there. There's no distinction between math and physical reality, like Penrose said. He says that the universe doesn't have mathematical properties. It is a mathematical structure. End of story. And so he talks about these different multiverses and every mathematically consistent structure exists as a physical universe, and our universe is just a specific piece of math that happens to be complex enough to contain self-aware substructures, meaning us. But there's no baggage in this. He argues if we stripped away all the human baggage, the words, the descriptions, the feelings, the emotions, all that would remain is a purely mathematical description, and this description is reality itself. So that's what he argues here. Uh, okay, so we have two different points of view by two people that are arguably very smart people. Uh, they're taking the approach, uh, different approaches to the same problem. So what we end up with here with these two is uh, Penrose having a three-layer or maybe a two-layer view of Plato, whereas Tegmark says, no, there's really only one layer. He's not going to give in and say there's some special space where these things occur. And there, Penrose saying that there's a blueprint that the universe follows, which is due to mathematics. And Tegmark says, no, the reality itself, forget this blueprint, the reality itself has it baked into it that this is how the universe follows things. And consciousness, according to Penrose, is something that perceives these forms, but isn't the forms, whereas Tegmark says, nope, the consciousness is built in directly within the mathematics, and so it goes. So, uh, what do we end up with here? Well, let's look up one level, get away from the physics side of things, and we'll look at chemistry. Chemistry is where you take basic building blocks of uh, atoms and put them together to come up with materials. And the materials are made up of these atoms, which are basic elements that if we found in nature over the last period of time. So in ancient philosophy and in modern chemistry, we always find these platonic solids occurring here as a geometric blueprint that describe how matter is constructed. So when we go up a level in this, from what the physicists are dealing with, the chemists find that these platonic solids are there describing how things are structured. It's used again and again, as below, so above. So what in the world is going on here? Well, Plato used these as literal building blocks, but modern chemistry uses them to describe the distribution of the electrons around a nucleus. That's how you get bonds that occur between one atom and another. And these forms result in the physical shape of the nuclei being made up of protons and neutrons, these platonic forms. So the ancient view was that the solids served as the geometric blueprint, and Plato used them as the literal building blocks, but modern chemistry uses them to just describe the spatial distribution of the electrons around the nucleus. And this led to the ancient view of Plato's atomic geometry, where Plato proposed that the four classical elements, earth, air, water, fire, were made of atoms with shapes of the platonic solids. And so he chose fire to be associated with tetrahedron, air with octahedron, water with an icosahedron, and the earth with a cube, which is the most stable and solid, and so forth. But then he put in ether as a fifth element here, and that picked up the dodecahedron, and this was used for arranging constellations in the sky. So Plato ended up proposing five platonic solids that were used again and again to put things together. So the modern view of chemistry, though, is that there's electrons out there that are floating around nuclei, and they follow some geometric pattern, and that isn't that far off. There's examples here. For example, methane follows the shape of a tetrahedron, sulfur hexafluoride, an octahedron, and so forth. So it isn't that bad a call that these platonic forms are there in chemistry. It's just that it's up a level from what what the physicists are talking about, because now we're dealing with atoms, and this is all based on this valence or shell electron theory that is used today to compute what these things actually look like. Now, there's a chap named Robert Moon, and he put together what he called the Platonic nucleus. So he said, well, the reason we see these Platonic shapes in atoms is because they're these spherical harmonics, the music of the spheres. So when you try to distribute points, meaning electrons, on the surface of a sphere, which is the shell around the nucleus, the most stable or lowest energy configurations naturally result in being at vertices of these Platonic solids. So he proposed a model where the protons inside the nucleus are arranged at the vertices of nested Platonic solids. So he started with the tetrahedron on the inside with 2 protons. Then he went with a cube that had 8 protons, an octahedron with 6 protons, and an icosahedron with 12 protons. And this shows how the symmetry here is just baked into this world of the atom. And it's not to disparage his thought. No one has really picked up on what he did. It's just that they're kind of scratching their heads going, what could I do now that I couldn't do before? Now, his theory works fine for anything that has an atomic number of up to 46. So going from 1 to 46, you can follow what he did. And so when you end up with elements that are beyond element number 46, which is palladium, for example, uranium, which is 92, which is twice 46, he said there's actually a twin structure and these things nest together and so forth. And so it's used again and again, but in 2 nests to create all these things. So he didn't give up on it. He accounted for everything. And he included the tetrahedron in this, which is what Plato had as one of his Platonic solids. Uh, just, but he left it out of this primary sequence. He said it plays a different role, maybe perhaps something to do with the geometry of space itself. He wasn't clear what it was. So the tetrahedron is for him in left field. Now, let's step up one more level from chemistry. Let's go to biology and look at their Platonic forms in biology. Well, the intersection of biology and philosophy is really leads to this idea of mathematical attractors that guide the development of life. So here, the basic idea is for humans, it's been observed that you have an egg and a sperm, and they link up together, and then you have a little embryo of one cell, and it starts to divide, and it divides and it divides and divides. But when it gets up to about 200 cells, all of a sudden things change. And the cells, they're still dividing, but this becomes a bone cell, and that becomes a neuron cell, and that becomes a skin cell, and that becomes a hair cell, and so forth. So you end up with these forms, which are going to make up the human body, being baked in at a very early stage into these embryos. And the embryos are now that they've reached a certain mass, they're going to just start to fill out the form. So you'll have eyes, ears, mouths, arms, legs, fingernails, everything else. But the concept of this is you transition from something that's abstract, which is this form, to something that's very real, which is a human body. And that guides the development of your life. So the 2 people that we focused on in the past in this, in what we call biological Platonism, are Darcy Wentworth Thompson and Michael Levin. And while they lived a century apart, they both shared a core belief biology is not just a result of random genetic actions, but is pulled towards specific geometric and logical forms. Trees, flowers, rocks, You name it, it's all in this. Marjorie has done a lot on Darcy Wentworth Thompson. Do you want to talk about this?
Hmm. I had never encountered anything like it when I was asked by a colleague if I wanted to write an essay for a,
A book.
a scholarly journal that was coming out on I think it was a, a textbook on biology for a publisher called Jesus. I'm not gonna I'm blanking on it. And so I had to get a copy of the book, which was about this thick. I don't think we have a copy here with it. And it was
It's called On Growth and Form.
on growth and form, loaded with diagrams and photographs, wonderful illustrations, and lots of charts and graphs because he was really into ratios um, of growth and things like that. And I was enthralled. I had never seen anything like it. There's so much mathematical precision in the way things grow in biological forms of life forms from so when was he was
Well, the book was in 1917, but he was doing this well
right,
before it, 1880. It's just 30, 40 years of work in this book.
right, and he was younger than Darwin and felt that Darwin was completely misguided and barking up the wrong tree. And
This is this is the interesting. Why don't you read this?
Thompson's most famous contribution was showing that you could place the skull of one species on a Cartesian grid and through a simple mathematical warping, stretching, or shearing, this way of twisting, um, that grid perfectly map it into the skull of a completely different species. So they're all kind of created on the same grid. Um,
This is the power of algorithms to be able to do this. That's what he's describing by this warping. That's an algorithm.
and he believed forms like the logarithmic spiral found in snail shells and ram horns, or the hexagonal packing found in a honeycomb, were free lunches from physics. Forms that matter must take because of the way the universe is built. And it's just fascinating how he worked out all these ratios and you know you get this image of this creator with a slide rule and a protractor
But
working it all out.
this is the Platonic connection.
And this implies that there is a universal form or an underlying geometric archetype. Species aren't just collections of traits, they're variations of a single mathematical structure. And you can really see it the way he lays out his hypothesis in this book. Um, he was a triple scholar, which is what I think made him so unusual. He was an expert at geometry, biology, and classics. And he was fluent in Greek and Latin. And so he was reading lots of ancient texts and translating a lot of them. and reading all the great thinkers in the raw and postulating from it in this way that he was uniquely qualified to do. Um, and putting it together in this totally unusual way that showed that things were really mathematically driven. It's like that's the underlying archetype of reality is this geometric uh, grid that kind of forces things into these patterns. And they grow the way they grow because they have to. That's sort of the conclusion you come away with is this deep sense of necessitas driving things. And for me, this was just utterly fascinating. And it was a different view of what you could call God. Um, is that it was guiding principles of creation, not in this necessitas, that things are the way they are because they have to be. And that it wasn't like a personality working with a slide rule and a protractor. It was these underlying principles that are just woven into the fabric of the way things are. Fractals are just part of the way things are, and spirals. And he loved the Fibonacci sequence, otherwise known as the golden ratio. And you just see that in plants and seashells and everything, galaxies. And if it's not that ratio, it's another ratio. One or the other. And that was kind of what drove his whole um, theory. It was much deeper, much more profound than Darwin. He makes Darwin look like a child in comparison.
That's one reason why he waited till 1917 to publish his book was because he knew there'd be a firestorm of people attacking him. But for example, it suggests that this is a way to better health. That if you knew what the right form was for your body, when you're sick, you're not in that right form. There's some problem someplace. But if you can resonate your body back to the correct form, your healthy form, then you'll be cured. So that'll take care of cancer. You'll live longer. It'll be a much happier, fuller life, is what's implicit in what he was saying. So
They help things grow. They are limitation, but um I don't know how to put it. They make things possible. These forms, um these ratios, and it's all over nature in ways that the photographs in his book and the diagrams are just phenomenal for making his point. And it shows that he's not interpreting anything. That's the reality that's there. It's objectively there. He's not discovering it, he's just making note of it and putting it out. And the patterns that emerge, it utterly changed my view of reality. And I realized that it's definitely what's behind astrology that I don't think a lot of astrologers even realize. And its most basic, it's geometry. It's astrology is looking at the relationships between the planets. Each one is in its own orbit, and there's they're in a spiral. There's no way around that. And it seems that they were, pulled into the gravity field of the sun one at a time. but they are following this ratio. That seems impossible. It seems like you're hallucinating, but it's a spiral. But it's not the Fibonacci sequence, but it's a similar one. It's a different one. Um, and they're that distance apart. And it's really true, and it's not a matter of opinion, it's a matter of fact that they really
Yeah.
are. And there's even a blank spot for
What
meaning.
Marge is talking about is what's called Bode's law, which Bode stole from somebody else, but Bode got the credit for it. And so we start with Mercury, Venus, Earth, Mars, and there's certain ratios there for how far these planets are from the sun that follow this natural formula. So the formula predicts there'd be a planet between Mars and Jupiter, but instead what we see is a pile of rubble, an asteroid belt. And but then it follows Jupiter and Saturn and so forth. So the formula appears to hold. There's this order in our solar system, uh, but something happened to at the asteroid belt. There was a guy at the U.S. Naval Observatory in the 1960s who took his computers and traced all of these different meteors and asteroids and everything else, and he concluded that 3 million years ago there was a planet there and it got blown up, and what we see is meteors and asteroids are the remnants of that. Of course, his reward for publishing this was he was ostracized by the astronomical community. They couldn't believe it was that simple. But anyway, that's what he did.
It seems like those are the remnants of what was a planet, right where it should have been,
Right.
exactly where it belonged. And I think some were, pulled into orbit, more were pulled in to the asteroid belt, possibly, and several other planets besides Saturn have uh, rings
Yeah,
around them.
Jupiter has rings, just like Saturn. It's just that it's very hard to see them compared to the rings of Saturn.
And Uranus does as well, but I
Yeah,
think they're going in a vertical
yeah.
uh,
Well, that's because Uranus rotates.
rotates.
There is perpendicular. Uranus rotates 90 degrees away from all the rest of the planets, which makes you wonder what happened to Uranus.
They think it might have been knocked into
Right,
that
right.
position from it. It was horizontal in the past. Um, but it's just, I don't know. It's a wonderful view of necessity and order, and that it's, I don't know how to explain it. It was incredibly uplifting for me to read it, and
Sure.
I really enjoyed writing about it. Um, Maybe later we can show some of it. I found some good images to illustrate. I did an article about this at,
It's on our Aleph Talks website,
yeah,
so you can look at Margie's essay.
2002.
Yeah,
And it was just, for me, it was really uplifting and wonderful. For me, it was a different view of divine order,
right.
that it's more mathematical and it's for me, it was the perfect precursor to this class that we're doing, where we're talking about the intersection of spirituality and science. And that's what I got. That was my takeaway from it.
Right. So let's just skip ahead to Michael Levin, who's 100 years after Darcy Wentworth Thompson, and he calls this the Platonic morphospace. So he's taking Thompson's ideas, but he's 100 years later, and he's exploring how cells know which forms to build. And he calls this morphospace or morphology, a space of forms, as a Platonic realm. He says there's a space of possible shapes, and evolution doesn't have to invent every shape from scratch. it simply creates pointers that allow collections of cells to ingress or pull down a specific form from this abstract space. So the DNA for humans would pull down just the human form, but the form for humans involves a lot of different types of cells. But it uses bioelectric signals as well as DNA. So it's not simply the current push is always a biochemistry approach with DNA, RNA, and biochemistry driving everything, and very little emphasis on bioelectricity. But these are the signals that allow them to actually do anything to get the forms. And so uh,
It's like there's this inventory of possibilities of templates that can be
to
followed.
be a frog
Right.
as opposed to being an alligator or so forth. So um, what Levin did was he went ahead and he tried to see if you scramble the cells on the face of a tadpole, so the cells will actually navigate back to where they should be on the face of the frog. This is on a tadpole. The tadpole turns into a frog. So the tadpole has lots of extra cells, like extra eyes. What he put, like 50 eyes on a tadpole. Well, when all was said and done, the frog just had two eyes. It just magically went back there. So there was always a goal, which was a form or a platonic ideal that they were trying to reach. And the key thing here is that bioelectricity is really what's driving it. The genome is the hardware, but the software is really this bioelectric network that interfaces between the physical matter to the realm of forms. And of course, you won't find Levin's really the only one I found that's working on this. It's so obvious and profound, but it's just not what people want to hear. They want to hear the answer is always a pill, no matter the question. So if you're sick, here's a pill. You're all set. Well, maybe you're not. So the ideas here, Darcy Wentworth Thompson took geometric or physical constraints. Levin, 100 years later, deals with information or things he called attractors, okay? But the same idea. There's a mechanism here for doing it. Darcy Wentworth Thompson dealt with mechanical things. Michael Levin is dealing with bioelectricity and the memory that's in cells. Little an update over what was going on. The role of DNA is secondary to physical laws. Really, in both of them, Levin says, well, it's really a prompt to go access the right form that's out there. And so Darcy Wentworth Thompson viewed the universe as a sculptor, while Levin viewed the cell as a navigator that's doing all this, because the cell is really the basic thing. You just that the cells take on certain attributes. They draw on different forms to be able to do what they want to do.
And they seem to be like agents, they seem like living intelligent life forms.
Right, they are.
The cells, that you start to root for one when you're following its activity.
Right,
And as he's guiding the formation in a different direction, it's always motivated back to its original design, apparently,
right, right,
which it knows on some level.
right.
But each cell is like a life form, an individual animal, or organism in its own right.
Right. And this is where you see what Ron Cowan did, that these patterns or forms get displayed in different ways at different levels, in particle physics, in chemistry, in the shape of the bodies that we see around us in biological forms. It's an incredibly powerful concept and that's why we're spending the time on it, is to stress how important this is. So the thing about Darcy Wentworth Thompson and Michael Levin is that they're getting away from really what today would be called the bottom-up approach, where there's atoms, there's biochemistry, there's DNA and RNA as types of acids, and so forth. And they're saying that instead there's really a top-down influence, which is these forms that drive how the things get put together bottom up. And the Platonic space is this realm of mathematical and logical attractors. So it's a different space. And Ron suggested it's coating the walls of space itself, the ether, but so it is. But in implicit in that is the idea: I have a wing, I have a heart, I have a muscle, I have a toe, whatever it is.
That seems like a decision that's made in the beginning of the design.
Right.
And you can try and guide it away from there, and it just keeps coming back. So it's a mysterious thing. Well, who or what made that decision, and how?
Right.
That, to me, that's a really interesting thing. Is it the wing itself? Is it the bird itself? Is it some other designer outside? And it's so complex and elaborate and beautiful, and it works.
So they argue that evolution really ends up building biological antenna. So it's the cells and the electrical networks that connect the cells. The cells, each cell in your body has a 20 millivolt potential between the outside of the cell and the inside of the cell. There's a little potential there. So it's and you have 50 trillion cells in your body. So they're finding by these cells here, they're sensing what in the world is the right form? What should I be doing as a cell? And they tune into the specific form, and then they cause the matter to create that form. So it's a hair cell, it's a skin cell, it's whatever it is.
But they can fill in for each other too.
Right, they can.
They can substitute, and they know how to do that, and they know what part they are to the whole,
Right.
which is really
Yeah, you don't have an
intriguing.
eye growing out of your toe. Your eye, it says, oh, the eye has to be over here,
But
you know.
but the cells will decide to be an eye, or like in the salamander,
Right,
to replace an eye that was there. I don't know if they really replace eyes, but they will replace limbs. And it's just intriguing what aliveness is.
right,
It's such a miracle. And then how does that get decided and passed on and followed and replicated? And then over generations, this evolution takes place,
right.
And, and but it does seem to be by design. And I'm not saying it's a man with a beard on a throne in the clouds who's directing it from above. It's more like it's from within. It's from within the cells that know that they're becoming a leg.
Right, right. So they said a frog isn't just a biological machine, it's a physical manifestation of a form that existed long before the first frog ever hopped anywhere. So the idea of what it means to be a form of a frog was always there. It's built into these algorithms. Uh, Go figure what sort of algorithms these are. These are not trivial algorithms.
And somehow they emerge in this out of some, random cells become one thing or another. It's really
Right. So
mystery.
this is just a summary here, just now to catch our breath. So what we said is true reality is not what we see with our eyes. There's an arena, which is called space, but we fill it with ether. Ether makes up the foam, the discrete compartments. And when we put this ether into the arena, we get new behavior. And we end up with time that ends up being different as well. We have a notion of free will time And this leads to certain things. And then we have an Akashic record, which is what our soul keeps. So in the true reality, we find these forms or archetypes or algorithms are used again and again in our life, and they control. They not only control, they are they're controlling all the forces, but the language that does it is what we call mathematics. And each soul is a piece of this collective unconscious that connects everything. Everything is linked to everything. There's an immortal, immaterial soul that incarnates with this material body at birth and disincarnates at death. And so the purpose of life is perhaps individuation, to explore these archetypes and forms, to find the path which best resonates with your inner self, your soul.
Did you just change the view to this one? I just want to think, and
What do you want to do?
I want to see.
Oh, you want to see us?
Yeah,
Okay, there we
I
are.
just wondered how much light there was if we
Yeah,
both showed up.
yeah, you
I'm just
do.
sitting behind Bart in this other chair at a different height.
There you are.
Okay.
So our framework for the universe is there's an arena. That's this 24 spatial dimension space. Uh, that's where everything takes place. There's this ether, which is the foam that makes up space itself and leads to all kinds of amazing phenomena. There's also these things called vibrating strings that make up what become matter and dark matter. But they can in fact have some notion of being sentient because they're plugged into this energy. And then we have photons and neutrinos floating around and information. So this is kind of all the piece parts for what you need for any full theory of what's going on. But out of this, you end up with very, very rich layered phenomena. We saw chemistry built on top of physics and biology built on top of chemistry. So,
And there's so much electricity in that.
right,
That's
right.
intriguing to me. That's part of what life is.
So what Ron saw here, we put these pictures together years ago. The arena is 24 spatial dimensions. There's 10 here, there's 10 here, and there's 6 here. But the 4 that are here include time. So there's 2 different time dimensions, one for matter and one for dark matter. And there's structure with all of this. These compactified 6-dimensional spaces that are here have are so teeny we can't see them, but they exist at every point in space and time, and they have holes and they have curvatures to them. These parameters here called Hodge diamond. There's curvature and so forth. And a different way to display the same thing we just talked about was we have information that apparently lives in these compactified dimensions. That's where everything is happening. And we have physics here. For matter, there's 10 strings that are vibrating, and the energy in them becomes what we call particles, but it's really a jelly. And then that takes us up to chemistry and to biology, whereas for dark matter, there's 5 strings that vibrate, but there's no charge, there's no electrons here. So the only thing you end up with is a branching tree, a fern like structure for this dark matter. But it still becomes sentient, it still becomes active, and that's probably what's inside all the stars. The stars are going to have a lot of dark matter in them, but it's because it's at these very high temperatures, it's going to be very active and very, very sentient and so forth. So two different ways to display the same thing. The collective unconsciousness or the information goes everywhere. we go back now to just dig into this a little more. So the arena has 24 real dimensions, but 18 of them are compactified, or it has 12 complex dimensions in space, but 9 of them are compactified. And the relationship here in 24 real spatial dimensions leads us off to something called the Leech lattice, okay? A mathematician named Leech in 1965 discovered this lattice. And it's truly amazing. The fact that it has 24 in it and we have 24 spatial dimensions suggests there probably is some relationship here. I just don't know what it is, okay? So what he was looking at was how do I pack oranges, or if you will, spheres in 24 dimensions? So if we just start off with a simple example, in two-dimensional space, we can do a sphere, we can do a circle. And so if I put a circle down, I can draw, and the circle has a radius of unit 1, then I can put 6 circles around it that'll touch that one circle. So that's called its kissing number. 6 other circles can kiss one circle in the middle. If I go into three-dimensional space, I take a sphere. So how many spheres can touch one sphere in the middle? And the answer is 12, which is twice 6. Well, when you get up to 24-dimensional space, how many spheres in 24-dimensional space can kiss one another? Every sphere can touch 196,560 other spheres. There's a lot of spheres there, and it's the only one that can do this. But if you, for example, if you looked at doing this in 2 dimensions with a circle and the 6 circles around it, you'll see there's a lot of space there in between where the circles are and where there's uh, uh, no circle whatsoever. So there's a lot of wasted space. But in 24 dimensions, there's hardly any wasted space. They're really just packed in there in some crazy way, which no one understands. Why are they so packed in here? And then the other thing is that there's little shortcuts that people came up with in this 24 dimensional Leech lattice. The shortest distance between any 2 points is always 2, not 1. People have played games here trying to do shortcuts and trying to do other lattices, but there aren't any such things here in 24. And so there's something really funny about 24 dimensions that we do not understand, but so be it.
I just wanted to say that that thing about the circle can be surrounded by 6 circles of the same size is something considered to be sacred geometry
Right,
in our Western thinking, which comes out of ancient Greece that we know of, and probably, Atlantis before that, and or Egypt and along the way. And it's said to symbolize or, correspond with the 7 days of the week. And you see it in a lot of cathedrals and tiles and
right.
other sacred, designs and sacred architecture all over the world. And in all different cultures, they're aware of that rule. It's just a rule. It's like a just so thing. It's just the way it is.
Yeah. Yeah, I mean, there are in 2 dimensions, you have circles, you have equilateral triangles, you have squares, you have pentagons, octagons, you have all these two-dimensional platonic shapes. And then 3 dimensions, you have the three-dimensional versions of them, cubes and spheres, so forth.
And
Um,
that in 3 dimensions, it becomes a duodecahedron, and that's like this honeycomb shape when they're uh like tubes that are pressed into each other by their own weight.
right,
Just by their own weight, they will take on a hexagonal shape, and that's why honeycombs become hexagonal. They're
right.
created in these tubular columns like that their own weight crushes them into these hexagonal tubes. And Darcy Thompson did a fun essay on that.
Right.
Bees, were they making these hexagons because they wanted hexagons for
For honeycomb,
their
yeah,
cells for their honeycomb, or what was it? And it turns out it was just the necessary geometry that's the way the shape works.
there was no wasted shape. They
Right.
they 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 completely fitted it into one another.
And in 3D space, when they're compressed, that's what happens because it's what has to happen.
Right.
So it's not the bees or God, except whatever designed that correspondence, that rule, of compression and this malleable substance like the wax um, will be pushed and pulled by its own weight, that it has to take that shape.
Right. Right.
And in Darcy Whitman's time, all the scientists were always trying to come back to that they were proving the existence of God. Um, and this was an example of the proof. And was God guiding the behavior of the bees, or what? And then Thompson showed it's just the necessity
Right.
of the weight and gravity and the way things work, and that's 6 circles or tubes will become surrounded by 6 of the same size. And then if it's in 3D and spheres, it'll become 12.
Right.
That's just the way it has to be.
Right. Right. Yeah. So the other thing that came up we touched upon was how back in 1970, which as I look at things is 56 years ago now. I was asked to look at this exterior calculus due to this German Wilfried Grassmann, and he'd come up with a generalization of how you could take a scalar function that is a function that is just is a function of variables, but is a scalar, has no other attributes to it, and you can take its gradient, how it changes in each direction, and that gives you a vector as to how it changes in each direction. How do you generalize that? That's what Grassmann did. He came up with this notion of an exterior derivative and exterior calculus. And as a result of this, he developed all of Maxwell's equations in the 1840s. The only problem was nobody could understand anything he was doing. So it was all completely lost. It's there, but when everything is said and done, it's lost. So what Grassmann did was he took a scalar function. Physicists call it a gauge function, and when you take its exterior derivative, you get a vector potential. When you take the exterior derivative of the vector potential, you get electric and magnetic fields. When you take electric and magnetic fields, the exterior derivative of that are current densities. Take the exterior derivative of current densities, you end up with electric and magnetic sources. And so it goes. So this is entirely mathematical crank turning, has no physics in it whatsoever. But you get all of the equations from Maxwell. So this leads to this crazy combinatorial identity here, that speed of light squared times the magnetic susceptibility and the electric permeability that arise out of these equations has to equal 1. So this is totally a consequence of the geometry of the arena of space itself that comes out of this. No physics whatsoever. Now, having said that, uh, it gets to be interesting when you put something in space, and and uh, and so that's what starts to lead to some interesting actions. Just to spend some more time on this arena, though, we talked about there being 3 compactified subspaces, and so that obviously raises a question here. Is this what Yeshua called the Father, the Son, and the Holy Spirit? Were these 3 subspaces for each of these entities, yes or no? I don't know, but it's an obvious uh, leap of logic to come up with this. There's holes in the compactified subspace for matter. So two outstanding mathematical physicists, Ed Witten and Andrew Strominger, said that these would result in resonances for the electron, which has two other resonant things, a muon and a tau, and an electron neutrino, which has a muon neutrino and a tau neutrino. So there's really only an electron with the three holes and two resonances for it. And there's really only one tau electron neutrino and two resonances for that. So uh, when we looked at this for dark matter, there was a compactified subspace with four holes. So are there four resonances for the dark matter subquark that's there in this subspace? That's the question. And now there's 18 of these compactified dimensions. They have eight holes. So there's really only 10 dimensions, 18 minus 8, because the holes connect all the other spaces, dimensions together. So is this what is really going on in the tree of life in the Kabbalah with the 10 Sephirah? Yes or no? I don't know. But it's interesting that we find these sorts of numbers occurring here. And again, Ron observed at the start of our universe, there were two Higgs bosons, one for matter and one for dark matter. But he also observed at the end of our universe, neither one of them was there. That's why it was collapsing. There was no structure there. The Higgs bosons allow matter to take on mass. And when they zero out, like they did at the end of the universe, there's nothing there. You just collapse into something. And then we have these curvature characteristics just for space itself. And these lead to some interesting choices for these different compactified manifolds that are there.
Do you
So,
have an example of one?
yeah, I'm going to show that in a second. So the thing that comes up here, one of the reasons why people never pay attention to this stuff is they ask the obvious question, well, how many of these manifolds are there? Okay. I said I showed you an example according to what Ron saw, where there was one for matter and one for dark matter. And when you go through a particular construction method for doing this, you'll see that you can end up with 500 million of these, okay? 500 million of these manifolds. Well, that isn't too useful. Like, which of the where are the two out of the 500 million that I'd like to pick up, okay? But actually, when you get down to it, uh, there's there's really only maybe 7,890, or if I looked at the curvature pairs, there's really only 30,000 of them. So that's a lot better than 500 million, okay? But it still doesn't answer the question of how in the world do we pick up these these holes and these uh, things that Ron saw to winnow these numbers down. There's some more work that has to be done to get the thing sorted out. And here are some pictures of what some of these Claudio, I already told you there could be up to 500 million of these things. These are pictures in two dimensions of what these look like that are actually six dimensions long. So that all the compactified ones we're looking at are six dimensions, and you can see there's incredible variety here, and these things change over time. They're twisting and curving and spinning all over the place, and you can find incredible videos on the web. And so finally, we get around to putting the ether into the arena. So we fill the arena with these bubbles of ether foam to make up what we call space, what many call space, but here we use the term arena for space. And so what fills up the space or the arena is the ether. So with the ether in there, then you end up with an augmentation of the equations of electromagnetism because now you've got this fluid. It's an ether. And there's a very simple relationship where you end up with extra terms due to the density of the ether and so forth that would stabilize everything. And when you use these extra terms here, you discover that there's new phenomena that occur here. There's a so-called strong force that binds the protons together in the nucleus. That was not present, and you have a weak force where neutrons decay into protons and electrons, and that leads to isotopes there. And gravity itself is really just a change in the density of the ether. So everything comes out of electromagnetism, all the forces, when we put this ether in there. And this takes us to what Ron actually saw. He saw 10 closed strings here. He was able to stop them. That was the key thing. Other people have looked at these and they just see a blur, but Ron was able to reach out and stop them on deep meditation and draw these pictures. And when they resonate at hundreds of millions of times per second, the energy inside the strings fills it up like a jelly, which is what Ron is showing here. So there's a jelly, and it's actually a torus. There's a hole down through the middle. If I look on down the top of it, I see right down to the bottom of the hole. Here's the hole going through it. But this is really a jelly. It's really energy due to the resonance here. Now, if the Higgs boson were not present, then this would be gone, and the strings wouldn't be vibrating. There really isn't any reason for them to vibrate. And the other thing that Ron saw was the information blocks are coating the outside of this electron, these strings, and they're coating the walls of the compartments of space as well. And the only difference was for dark matter, instead of 10 closed strings, there's 5 closed strings, but everything else is the same, except that there is no charge. And so it goes. So incredible set of observations. The information blocks contain both the algorithms for these patterns or archetypes or forms, but they also appear to have storage. And these patterns work down at the subquark level on up to the galactic level and multiple galaxies level for creating patterns. So this is the work of art of an incredible painter, a super Picasso. And the information blocks themselves are all linked to one another, and they're constantly scanning for changes, and they act upon it. They control all the forces that are everywhere.
They're always communicating.
Right, absolutely. And the energy that's in the ether foam compartments that the Higgs boson releases is what's called dark energy. That's why they're vibrating like this, and that's what drives space apart. So Ron observed all this, the strings vibrating and everything.
By the
I
way,
think
we should say that Ron was Bruce's deceased twin brother.
yeah, they're what, half an hour apart in birth.
I'm the older one.
Yeah,
I always reminded him.
you're the elder brother.
Yeah, I was born first.
Okay,
They say that means he let you go first, just so
right,
you know.
right, right.
But
They-
they were both very advanced Buddhists, um,
Both,
meditators,
yeah,
and uh, Bruce was a full monk, was he not? I'm
Yeah,
sorry,
Ron was a monk. Yeah,
as
yeah,
your
Yeah,
Bruce,
he was ordained. Yeah.
yeah,
and a physics
yeah.
teacher.
And the thing that Ron observed was this dark matter. If it doesn't have any energy, if it doesn't have any vibration, to excite it, then it becomes quiescent. It just sits there. And he observed in deep space, 1,000-kilometer long tubes of dark matter just floating between the stars, none of which modern astronomy has seen yet, but he suggests that it's there and you should be looking for it. I think that, I've underestimated this. I think they were hundreds of thousands of kilometers long. But there's a lot of room out there in space, so it goes.
And they're seem to be kind of waiting to be activated to become.
Right. Right. If they got close to a star, then they'd start to get heated up and then they'd become sentient. But so it goes. And Ron looked at the subquarks, and they actually hopped from one compartment to another in the foam of space. So that's how they moved, was by hopping. But there was an exclusion principle here. He never saw more than two subquarks in a single space compartment. So there's something funny going on there that it has to be accounted for in some theory. There's some sort of energy state of two subquarks, like up and down, is all you can have. And so any sort of complete theory of this has to include the strings, as we saw, and the photons that create electromagnetism, but it also has to include the space itself to have a complete theory of everything. And this is what we need for physics.
And the space seems to have an inherent um, intelligence or consciousness.
Right, right,
That,
due
that,
to the
that's,
information that coats it.
right, that's
Yeah,
interacting with
right.
other spaces, with itself, with whatever's in the space. It's really surreal.
So what the key thing that Ron saw here was there's two time dimensions, okay? We have a 10-dimensional subspace for matter and another for submatter, for dark matter, but they each have their own time dimension, and that appears to be a real and imaginary part of a single complex time dimension. So in the subspace for matter, we think that the time dimension reflects this many worlds interpretation of quantum mechanics. At every transition epoch, say an electron in an atom hops from one energy level to another in any atom, that creates a new timeline. And we can pick and choose which timeline do we want to be on. Do we want to stay on this one, or do we want to go to the one that the energy level occurred to? And this creates the notion of free will here. And the same thing in dark matter, but here with dark matter, uh, this is not the case that there's many timelines being created. Here, there's only a single timeline, what's called an Akashic thread, that starts at the start of the universe and goes to the end of the universe, and that is it. So whatever timeline we're following on here, hopping around, we can apparently, with our consciousness, collect these timelines so they group that they're close to one another. So the timeline that you see and the timeline that I see are really pretty much the same. And that gets recorded in our Akashic threads. For each of us, our soul is recording this. It's the ultimate holographic full color movie that you'd want to see of your life. That is your Akashic thread, and so it goes. And the free will of the participants allows us to control these timelines to pick and choose which one we want to be on. And so, for example, we looked in the quatrains of Nostradamus, and Nostradamus foresaw Napoleon and Hitler, but he also saw an Antichrist that was here in our times to create incredible havoc in the world. But the Antichrist is not creating this havoc. He could very well have been born, and he could very well still be someplace on Earth, but he is not able to do what he could do because our timeline is different. And this is why Nostradamus wrote the quatrains. He said, I see this future and I don't like it. And other people saw it and they said, we don't like it. And they forced our collective consciousness off this timeline, away from this Antichrist. So that takes us up to sentience, which is linked to either matter or to dark matter, or to energy. Energy itself can be sentient. We can have energy beings that are sentient. And the energy entities are attracted to incarnate with the matter or dark matter entities through a lifetime in order to gain experiences they couldn't get otherwise. And this allows them to have greater individuation over multiple incarnations. So in human beings, the body contains chakras that are apparently dark matter. Ron observed this, and they're energetically linked to one another to create an energy entity or a soul that incarnates at birth and disincarnates at death. So there we go. I'm going to shut this thing down for a second, and let's see where we're at.